Hi, my name is Sergey, and today we will talk about how a computer operates the data, how it stores the data, and how it actually lives in digital world. Almost everything around us were in analog world. For example, these watches. It uses analog system because the changes are smooth and continuous. But computer works in digital world, where everything made up of discrete bits, like tiny switches. And think of it like lighting a bulb and infinite amount of bulbs. Computer use electricity to represent everything with on-off switches. As more on-off switches you have inside of your computer, as more data you can process. In the past, we had such a huge computers that took a whole room or a whole table for a computer that did not do much. It's because these computers had very big on-off switches. And nowadays we have really small switches, and amount of these switches is much higher. These switches represent just two states, on and off, or 1 or 0. That means it represents a binary value, and everything is made of power of 2. It's very easy because one switch can represent 2 values. 2 switches can represent 4 values. 3 switches can represent 8 values, and this is exponential. How it is possible? For example, one switch, it can be either on or off. 2 switches can be both off, both on, one on, one off, or for example, one off and one on. So it's 2 switches but 4 combination. 3 switches, 8 combination, 4 switches, 16 combination, and so on. 8 switches, it's already 256 combinations, and that's a lot. For example, if we will take UTF-8 character set, which represents English alphabet plus numbers plus special characters like plus, minus, square brackets, quotes, whatever, we have 256 different values. And our computer knows that this value represents a lowercase, this value represents a uppercase, this value represents b lowercase, and so on. So before start working, we are saying our computer, hey, this is metadata, please use this character set, like it is UTF-8, and then these combinations you will get later will be represented in UTF-8, and you can read this text using this character set. And with 0 and 1s, you can represent not only text, you can also represent images or videos or audio. It's also some changes of 0 and 1s. And as our word contains from multiple letters and sentences contains from multiple words, we can also combine bits together to get something bigger. For example, bytes. One bit is just 1 bit, 8 bit is already 1 byte, and so on. We can group this data by bytes. 224 bytes, it's already kilobyte. 224 kilobytes, it's already megabyte. 224 megabytes is a gigabyte. Why it's 124? Because it's some value power of 2. And it's exactly 2 power of 10. 2 power of 10 is 124 bit. But how do computers make sense of these 0 and 1s? Enter the world of binary logic. It's a set of rules that combines these switches in different logical positions. Usually it is positioned like AND, or not. And imagine these switches connected in a specific way. If you are turning one switch on, it can affect another switch to be on or off. So changing these switches to on and off is actually processing the data. And this rules is predefined, and actually predefined in the hardware level. So that's not what we should worry about when we are working with high-level programming languages. What we should worry about is about these states, on and off. In binary, it usually represents true or false. For example, we can ask a question, should this program still run, or should we continue doing something, or is this picture contain a cat, or whatever. And basic math relies on binary. Adding two numbers is like flipping two switches with some specific rule. It is important to mention that binary works well with whole numbers, but works bad with fractional numbers, because whole numbers, integer numbers, can be easily represented with exponential. 4 is 2 power of 2, 5 is 2 power of 2 plus 1, and so on. But with fractional numbers or values with floating point is a bit different. We need to use binary for this, and to represent a fractional number we need to use exponent of minus something. In binary we cannot simply represent 0.1 or 0.2. We represent it with some exponential values which is close to these values but not equal. That's why when we are adding 0.1 plus 0.2, we will not get 0.3, which is obvious for us because we are using decimal numeric system, but not obvious for computers because computers works differently. Computer works with binary logic, and in high-level languages, computers usually do some assumption that it might be 1.3, but it's actually not. When you're adding 0.1 plus 0.2, you will not get 0.3. You will get some value close to this, but not equal to this. Computer will do assumption and calculate, hey, it's probably 0.3. But in low-level programming languages, you should think about it. It's not equal. As I already mentioned, we and computers using different numeric system. Computers using binary numeric system, and humans usually use decimal numeric systems. That means that computers using binary values 0 and 1, or true or false, and humans using decimal characters from 1 to 10, or from 0 to 9. But there are also octal numeric system with base of 8, with values from 0 to 7. It was used widely in the past, but its usage has declined over time. Nowadays, in computers world, most programmers prefer hexadecimal numeric system because of its compact representation and ease conversion to binary. Octal use 3 bits because it's 2 power of 3 and represents 8 combinations, and hexadecimal use 4 bits to represent 16 combinations, and it is simpler, but we don't have enough numbers. That's why we are using letters from English alphabet from A to F. Hexadecimal commonly used in programming for memory addresses, color representation, or binary file formats. Usually when you see a binary value, you just see 0 or 1s, or it can have a prefix 0b. Decimal values is usually decimal values. If it's octal values, you might see leading 0 in the front of number that will say, hey, it's not decimal number, it's actually octal number. And for hexadecimal, you can see a prefix 0x. Of course, if hexadecimal numbers will have only numbers, not letters, you will see with this prefix that it's not actually decimal number, but it's octal number. For image representation, programmers widely use hexadecimal numbers because it's easier, and I'll explain why. There are two most widely used models, RGB and CMYK. RGB model represents emitted light, and CMYK represents reflected light. Most programmers usually work with RGB model because we are working with our monitors or displays that actually emits the light, and if we want to change the color of a button on the screen, we would work with RGB model that actually emits the light, and with 3 different colors you can build whatever color you want. Mixing red, green and blue will give you any color you want, because every of this color, red, green or blue, can be represented with values from 0 to 225. That means you have 256 combination of red color, 256 combination of green color, and 256 combination of blue color. If you multiply these values, you will get more than 16 millions of colors in total. It represents almost every color known by human. And that's enough to draw whatever color. And 0 is actually nothing, and 255 is maximum value. That means if you have 0, there is no color. If you want to have a light on your screen, you're increasing this value. When we are using a hexadecimal system, instead of writing 255, we can write just FF. You don't need to remember all combination or instantly count hexadecimal values to decimal or whatever. It's just simpler to write just FF instead 255, or 1F instead of decimal representation of it. It's just shorter, and for computers it's just easier to calculate it to binary value. But there is also CMYK model, which actually represents a color which will be reflected by light, not emitted by light. Our monitors emit the light, but physical objects around us actually reflect the light from sun, or the light from light bulb or whatever. And you can prove this because during the night there is no light, but when you have some lighters and flash it to whatever object, you will see its color. Even during the day, you might not have direct contact with the light, with the sun, but you will still see light around you, because light reflects from different objects and you see their color. If color of object is black, that means this object did not reflect anything. It consumed all light it gets from source, for example, from the sun. That's why CMYK model is completely different from RGB model, because if 0, 0, 0 in RGB will represent black, and 255, 255, 255 or FF will represent white color in RGB model. In CMYK model it will be different, because CMYK represents a value of reflected colors, and if you go to some store to buy a paint to paint your car or whatever, you will be asked not for RGB values, you will be probably asked for CMYK values or whatever. But it's already too much about how computers processing data. I hope it was interesting for you. I hope you learned something new. If you have any question, please do not hesitate to ask them in a comment. I'll try to answer to all your questions and be helpful to you. In the next episode of this series, How Computer Works, I will talk about hardware, how it's connected to each other, how it produces the data, how it operates the data, stores the data, whatever. So see you in the next video. See you soon.